The system used by our PRESSOVAC series casting machines was specially developed for dental labs where casting perfection is absolute. Casting pieces have a very smooth surface, a very dense molecular structure, and without defects like improper filling, porosity, and shrinkage. Metal is inserted into the crucible and the flask positioned on the cradle inside the casting chamber. Casting cycle is fully automatic. The casting chamber is fully evacuated by vacuum before melting, followed by helium gas supply to create an inert atmosphere. Helium gas has an excellent gas fluidity, which provides a cleaning effect of the molten metal and mould and guarantees a smooth filling of metal even of the most intricate patterns. The casting temperature is attained, and low-frequency pulses are given to vibrate and mix the molten metal by keeping it homogeneous. Temperature is controlled by an optical pyrometer up to 2100 degrees centigrade for platinum, steel and titanium, and by an immersion-type S thermocouple inside the graphite crucible up to 1500 degrees centigrade for gold, silver and bronze. At this stage, just by pushing a button, the whole crucible and flask system will automatically rotate through 90 degrees, and the metal, once poured in a homogeneous and controlled way into the flask, is automatically pressurized to 4 bars by argon gas. This high and quick pressurization is indispensable to obtain a proper and homogeneous filling, even at low metal flask temperatures for gold, silver and bronze alloys, and, above all, for platinum and special steels which have a very narrow melting interval, thus a very quick solidification. This results in a very smooth surface due to the effect of the vacuum, and a dense, well-compacted casting due to the overpressure of 4 bars, which benefits both thick and thin sections. In most of our competitors' machines, the metal cannot be effectively pressurized up to 4 bars since the machine structure is weak and gas pressure is slowly applied to the molten metal after pouring. This weak and slow overpressure leads to a raising of the temperature of both metal and flask in order to obtain a proper filling of flask, with the obvious consequence that casting pieces will have porosity and very rough surface due to the very high temperature. Furthermore, in the competitor's machine, the casting tilting system is manual. It's not constant, nor homogeneous, and this leads to either a slow pouring, which will cause improper metal filling, or too quick, and metal will be spilled outside the flask.